Hello, 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 everybody. Getting ready for class here today. It is 2:01, and Hutch Johnson here from Valley News Live. Very excited to be here, excited to have you on board. And as always, I'd really love to have you, first and foremost, hit the like button and let me know in the comments section below where you're watching from. We've had folks joining us from Texas, from Germany, from, here in the Valley, of course, but it's also awesome to know that you've shared this with friends of yours from across the country. First and foremost, this has been an interesting week for all of us here across our world, really. It's not just the United States. It's not just us here in the Valley in particular. And boy, us kids, we're having to find different ways to learn. We're home from school and, at work here. I don't know if you can see around, but, here, let me show you around. Let me just use the camera. Very quiet around here, even at the television station, okay? This is the studio, and this is where we do all of our live broadcasts from. Sorry for the shakiness of my little camera work here, but I got to tell you, even our station has really changed. It's a lot quieter. For class today, I need you to go get a couple things before we really get going with the content today. Hutch has balloons, so if you have balloons again at your house, we used a balloon the other day. Grab a balloon for each of the kids that's there if you have one. If not, share. It's okay. We can do it that way too. Hi, Victoria. Thanks for joining us from Fargo. Jill in Breckenridge, thanks for joining us. Jack in West Fargo and Heather, thanks for watching. Angie, thanks for having Emily and Kirsten watching. Good to have all of you fine folks joining me for today's weather class. Now, this is about an exciting topic, and it's one of the reasons why Hutch was really excited about weather when I was just a youngster. I always looked at clouds and thought they're amazing how they form. So we talked about that when we talked about clouds the other day. But when a thunderstorm comes by and you see a bolt of lightning go from the cloud to the ground, and you scratch your head and you go, how does that happen? How do we learn about that? If you're in research meteorology and you want to learn more about lightning, how do you study lightning safely so that you don't get struck? We're going to talk a lot about all of these. Dawn joining us again from Alabama. Roll Tide Roll, if you're on board with that. Good to have you on board. Isaac and Zeke. Kaysen, 10 from Fargo. Thanks for joining us. TJ in Grafton. Wow, we got a lot of folks joining us. Mason from Wisconsin. Thank you, Mason, for joining us. I hope the cheese is good. I love cheese. I had me some cheesy broccoli for dinner last night, and it was outstanding. Jordan from Fargo, hi, and the Haas family from Valley City. Thanks a lot. Okay, I want to tell you, first and foremost, I have to take a minute and thank our sponsors, and that is our friends at Luther Family Ford here in Fargo. They sponsor our Weather Kid program, and because kids are at home now and there's no school, we're not doing the Weather Kid program. So to come up with an idea here, we had Hutch's class. So it's one of the things. What about Hutch? What's Hutch? Hutch is a chief meteorologist here for the CBS and NBC affiliate in Fargo, North Dakota. I have been studying weather for many, many years, almost 30. Okay? And I've been working in TV for almost 25 years. I teach and have taught college-level meteorology classes, introduction to meteorology, and a lab that goes with it at Bismarck State College, and I did that for almost 20 years. So I'm used to teaching. I love talking about weather. A lot of you have asked questions, and I've gone through and read all your questions that you have typed up on my previous classes. Thank you, thank you. If you think of questions today, write them down and then share them with us at the end. And if I don't get it to them there, I will answer them. Love your questions. One of the comments I've been seeing a lot is, Hutch, do you like your job? Just to let everybody out there know, if you cannot tell, Hutch loves his job. Every day I get to come to work and do what I enjoy. And that's math. I like numbers, and the science of meteorology is amazing to learn and to understand. And it's a science that keeps changing, right? It's a science that we always can learn more. When I was in college and when I was in school, we were just starting to study things like El Nino and La Nina, and we were just starting to really get in depth with thunderstorm and tornado research back in those days. So we've learned so much more now than we did before. How hot is a bolt of lightning, Samantha? Thanks for your question. That's awesome. And we are covering that today. This is a touchdown symbol, which we haven't seen for a long time. In fact, any sports symbols we haven't seen. Elizabeth, good afternoon. Hope Thief River Falls is doing great. We appreciate you for joining us. Let's take a look here. I got to pull up. I'm setting up too. So I really also appreciate your patience with us. We work in a broadcast television station. We have a lot of equipment here. Big, expensive cameras, switchers. I'm just doing this like you would do this. I've got my cell phone here. I'm talking to you on my cell phone. I have had problems with my cell phone's signal from time to time, causing a signal to come and go. Sometimes the audio fluctuates, and I've been working on improving that each day. I hope that things are coming through loud and clear. Annabelle in Winger, Minnesota, thanks for joining us. Wendell, thanks a lot. You don't look that old for all the teaching you've been doing. Oh, Wendell, thank you. Thank you very much. I'll take that as a beautiful compliment. I've loved what I do. I've done it for a long time. I went to college for meteorology in the Denver area, so I studied a lot of mountain meteorology as well. And for 5 years, the first 5 years of my career, I worked in research meteorology, the scientist stuff, where we went out and studied. Particularly, I worked with Doppler, LIDARs, laser radars. So I played with lasers. What could be more fun than that? It was a lot of fun. Okay, remember, for class today, if you have it, make a run, get yourself a balloon or two. Hutch has a couple of other things, including an apple, because I'm teaching. I'll get to that later. Let's get to the material today, and that's lightning. It's a shocking subject, and here's a graphic I've prepared for you. Thanks so much, Vicki and Alicia, for joining us. How can lightning get from the sky to the ground? I am going to answer that today. Tony, hey, you good? And you are good too. All right, thanks everybody for all the kind words. It seems to get windier each year, Kim says. Why does that happen? Well, we talked about wind the other day. Some years are windier than others, and wind is driven by pressure changes, and pressure changes happen when we have big temperature changes. So the bigger our temperature difference across an area, well, the windier it gets. And here in North Dakota, we don't have many trees to slow down the wind, right? If you live in Minnesota where there's like the pine trees up there in the Northland, or if you're in lakes country where lakes and there's a lot of water and wet soil to make a lot of trees, those trees help block the wind. North Dakota, I mean, there's a funny saying here for those of you not in North Dakota. North Dakota is a state where you can watch your dog run away for 2 weeks, because there's no trees to block your view. All right, I'm not a comedian, but I'll get back to the topic today. Lightning, thunder, and it's all so exciting. One of the subjects I wanted to learn more about. Here are a couple of facts. Number one, lightning heats the air to 50,000 degrees. That's 5 times hotter than the surface of the sun. The surface of the sun is about 10,000 degrees. How does Hutch measure the temperature of lightning? Did I stand there with a thermometer under a lightning bolt? No way. No way. But we can tell by the colors and the amount of energy radiated from lightning bolts based on the color spectrum that it makes, what the temperature of that lightning strike is. And lightning heats the air to 50,000 degrees. That's super duper hot. Another fact about lightning. You might have heard lightning can never strike the same place twice. Sometimes it does that in a second. It can strike the same place a dozen or more times. Okay? Lightning strikes television towers, radio towers, and tall objects. Melanie says, I hate lightning. And I agree a little bit with Melanie. Lightning is very hard to predict. Okay? Lightning turns a cow black under its hide when it's struck. Kim, I did not know that. I've never seen a cow struck by lightning, but many cattle do get struck by lightning. That's an interesting fact that you shared there, Kim. Thank you for that. Lightning, by definition, occurs in all thunderstorms. Thunderstorms create lightning. So that's where lightning comes from. Now, a couple of facts about lightning. There is a lot of different types of lightning, but lightning versus thunder. What do you know about the difference between lightning versus thunder? Go ahead, kids, and type down your answers, because I'll be reading these later. What's the difference between lightning and thunder? How many colors can lightning be? Well, if you look at the picture here, it looks very white, and sometimes it looks yellow, and sometimes it looks red and purple. It just depends what color that it puts out based on what it's hitting, how much electricity is there. How do thunder and lightning work together? Let's answer that, Byron. Let's answer that question right there. Lightning. Lightning is the light that we see. So when you're watching a thunderstorm from a safe distance, okay, from a long ways away, somewhere safe, we'll talk about safety here in a little bit. From the distance, you see a flash. That's the lightning. You see lightning. You hear thunder. That's the difference. Now, because lightning heats a column of air up to 50,000 degrees, that air gets really hot and it expands, okay? Remember, hot air can change its volume. So the hotter we make it, the more it expands. So if we heat up air just a little bit, it'll expand, but if you heat it up to 50,000 degrees, it really expands. The air around the lightning strike, all around the lightning strike, it's a narrow little bead. And the size of a lightning strike, I don't have a pencil handy, the size of the current is about the size of the lead in your pencil as far as how big the current is. But it looks huge because it lights up as it heats the atmosphere. It looks huge, okay? The colder air around the lightning bolt channel collapses, okay, into the channel, and you get a clap of thunder. We hear thunder, we see the lightning. Lightning happens first. Lightning happens, we see it first because we can see things happen before we can hear things happen that are happening at a distance, because light travels at the speed of light, which is super fast, okay? But sound is not as fast. Sound travels in our atmosphere at about 700 miles per hour. And that's how fast it is. Now, that seems pretty fast to you and me, but lightning happens almost instantaneously, and the sound gets to our ears later. So you'll see the lightning bolt first, and then you'll hear the rumble of thunder. And there's a rule that you can use if you want to write this down when you're watching a thunderstorm. If you watch a thunderstorm from a safe distance and you see a bolt of lightning strike, whoosh, start counting. Mississippi 1, Mississippi 2, Mississippi 3, Mississippi 4, Mississippi 5. 5 seconds is how long it takes for that sound to travel 1 mile. Okay? So for every time you count to 5, that lightning bolt was a mile away. So if we counted to 15 seconds, Mississippi 1, Mississippi 2, Mississippi 15. If we get to Mississippi 15, how many miles away was that lightning strike? Okay, 15, but it can go 5 seconds per mile. So 15 divided by 5 is 3. It's 3 miles away. That's how you do the math, okay? So if you can hear thunder, meteorologists say it's best to get inside, because we can hear thunder from almost 20 to 30 miles away, okay? So when a storm is getting that close, we're close enough to be struck by lightning, and it's best to get inside. All right, let's take a look now at the next image I have set up for you with some more lightning facts. Lightning types. Lightning types. There's a lot of different types of lightning, and I've seen some of you mentioning these types of lightning on the broadcast today. So I think that's very cool. Now, we can have lightning take place inside the cloud, okay? That's called cloud-to-cloud lightning. That doesn't strike us. It doesn't shock us. It lights up the night sky beautifully, okay? And down below on the last line, you'll see heat lightning. That's what heat lightning is. When at a distance, you can see those clouds lighting up. So we live in Fargo. I live in Fargo area. If I'm looking at a storm that's out near Jamestown at night that's moving my way, I can see those clouds. They're 100 miles away, but because those thunderstorm clouds are so tall, I can see them from a long ways away. And that lightning in the sky that you see kind of flashing in the clouds in the distance is called heat lightning. We can have cloud-to-cloud lightning inside a cloud or a partner cloud next to it. That's cloud-to-cloud lightning. Again, that's not too dangerous for us. Cloud-to-ground lightning is dangerous for us. That's when the electricity and the current jumps from the cloud to the ground. Those are the ones that are the most dangerous for us people and cows here on the ground. We can have forked lightning. That's kind of what this picture is showing you a picture of. Okay. And anyway, there is your some different types of lightning. Now, at the very bottom, special types of lightning. Heat lightning, I explained that. Ball lightning. A lot of you have had questions about ball lightning. And ball lightning is something that Hutch has never seen. I've never seen it. So it's hard to understand and very hard to study things that we cannot see, can't touch, can't understand. But I've seen video pieces of what looks like ball lightning, and if they're real, it's amazing. And it's a little electrified ball that travels through, and it almost looks like a spaceship hovering through the sky. Okay. Sprites and Jets are some recently discovered things where energy discharges from the top of thunderstorms out towards outer space. So not only do thunderstorms discharge energy toward the surface, but other higher layers in the atmosphere or in the lower levels of space. Really cool stuff. Okay, today's satellite and radar shows that across our nation, we got to have clouds to have a chance at making thunder and lightning. And we have a bunch of clouds down here in the nation's midsection. And lightning comes from thunderstorms. So we got to find an area where we might have thunderstorms. Thunderstorms are usually very small. Okay, they're about 10 miles in diameter on average, and they impact a very small area as they move across. But thunderstorms are the ones that make the types of clouds that lightning happens from. Wintertime clouds, the stratus type clouds we get, those are not quite the type of clouds that are going to have enough oomph to make lightning. And I'll explain why here in a second. But first, let's take a look at a couple of safety things to understand with lightning. And you know what? I think I'm going to, give me just a second while I put my computer in play mode. I'm going to jump through a couple graphics here. I apologize for that. Okay, jumping, back getting to where I was. My computer's going to behave a little better. So these, near Oklahoma City, these showers that we see are likely thunderstorms, okay? And we can tell that because there's a lot of red on the radar. So when you see red on Hutch's radar screen or your local television station, those are very heavy rain showers and sometimes or oftentimes can be associated with thunder and lightning. Now, I do want to point out that thunderstorms that create lightning reach tall heights in the atmosphere. So if Hutch takes a look at this area here, this is a house around a thunderstorm. And let's talk about where we can be safe first and foremost. We can be safer inside. You don't want to be near tall objects like trees. You don't want to be holding a baseball bat. You don't want to be on the roof of your house watching the storm and recording video of it. You need to get inside to protect yourself as much as possible from the lightning. Now, we have other areas that we mentioned that you can go. Cars can offer some protection from lightning. Cars get struck all the time. Now, when Hutch talks to students in classrooms and I go to schools, I ask kids, why? Why are you safe in a car from lightning? And the answer I get is because the tires are made of rubber, Hutch. Well, nope, that little slab of rubber is not going to stop a lightning bolt that traveled through miles of atmosphere to get to the ground. That's right, Tony. Aluminum? Well, it's the metal of the car. Okay? Metal is a wonderful conductor of electricity. So the current or the electricity in the lightning bolt hits the metal of the car and jumps to the ground. It travels through the metal instead of traveling through you. So a car is much safer than standing outside and is a way lot safer than standing under a tree. So this summer, if you get to play baseball, softball, soccer, and you see a thunderstorm coming and the game is postponed because of thunder and lightning, do not stand. Do not stand under a tree, right? It's tall. It's not safe to stand by metal objects like a fence. Okay, that's what happens to cattle. Cattle see thunderstorms coming and they moo. And they start walking and they walk and pace. And then they run into a barbed wire fence and then they stop walking because they can't walk no more. They've hit the fence. Moo. Lightning strikes somewhere close to the fence, and electrical current can go through the fence, and that electricity can travel through the metal in the fence for a long ways. And if there's 10 cows standing next to that fence touching it, then 10 cows can get electrocuted. Stay away from metal objects outside. You can, if you're at your baseball game in the summer, get into your car or minivan. Do not have the windows rolled down, chuckling at your friends, saying, hey, this is a cool thunderstorm. Look, do not have your arm touching the outside or metal of the vehicle. Stay inside the vehicle with the arms inside and the windows rolled up, okay? And again, I want to point out a couple of things here with Hutch's picture. Well, maybe we'll get to that in a second. Let's go to another safety item here. Okay, if you happen to be at the lake, who in Minnesota doesn't like to go to the more than 10,000 lakes we have? I do, okay? When you hear thunder coming towards the lake, it's time to get out of the water, get off the lake, and get inside. You do not want to be by a swimming pool, okay? Do not go in the pool during a thunderstorm. Eric, that is absolutely correct. You stay away from that. That's not a good place to be, okay? You want to keep yourself inside a house. Now, somebody just posted, I saw it flash by real quick, so I didn't see your name, and I apologize, but they said their grandmother was electrocuted on a phone. That can happen because electricity can hit electrical wires that are hanging in the town, and that current of the lightning strike, which is very large, huge amount of electricity, can travel through phone wires, and it can shock us. So really, during a thunderstorm, you should not be holding anything in your lap that's electronic. You shouldn't be on a phone with a wire. Even a cell phone is probably best to not have on you. People have had their laptops sitting on their lap plugged into the wall and have gotten burned from that. So don't sit too close to your television. You can watch the television. Don't have electronics in your hand, and try to avoid taking showers. Okay? Hutch doesn't like stinky people, but I shouldn't say that. We all have smells. I should say we got to take our showers, right? But not during a thunderstorm, because lightning can strike a tree in your yard, okay? And if lightning strikes the tree in your yard, then you are going to end up with that electricity going down into your ground through the trunk and into the roots. And that electricity can then, if those roots are touching your water pipes, water is a pretty good conductor of electricity. So the electrical current that hit the tree in your yard could send some small amount of that electrical current up your water lines and into your shower or bathtub. It's best to wait to do those things until after the storm has passed. So if you're outdoors in a thunderstorm, get inside if you can, get out of the water, away from the water, and stay away from tall objects. Don't go under a tree. Don't stand by tall things. Make yourself as short as you can if you're out camping, okay? And to do that, you can squat down. Hopefully you're not standing in a puddle of water, okay? Squat down and make yourself short. Make yourself the shortest thing around, not the tallest thing around. Inside, stay away from electronics, stay away from windows. Try not to take the bath or shower during the storm. And then when the storm is moving away and you no longer hear the thunder, then it's much safer for you to come on out. Now, I'm going to go swing around to graphics here again. And let me put this, I got to move my graphics computer around so I can get to the right graphics. Hi, everybody. Let's go to, oh, wait, maybe I didn't put that one in the sequence. Let me see. Yeah, let's go to this one. All right. I made a special graphic for this, and I forgot to put it in my sequence. Here we go, guys. This one's kind of fun. Okay, here's how lightning forms. And a lot of you have this question. Let's talk briefly about this. What we've learned, lightning requires cold clouds. And thunderstorms, as we talked about when we were talking about clouds, can be really, really tall. Thunderstorms start punching up through the lower atmosphere into the middle atmosphere, and they surpass 5,000 or 10,000 feet thick. And then they continue to grow vertically until they are upwards of 30, 40, or 50,000 feet. Now, there's important temperature that these clouds have to reach. As we go up through our atmosphere on a summer day, it might be hot down at the ground. It might be, let's say it's a nice warm summer day, 80 degrees here in Fargo. Okay? The rising column of air makes a thunderstorm cloud. As the air rises, it cools. So as we go up the cloud encounters cooler and cooler air, we find that when a cloud reaches about -10 to -15 degrees, that's when they start electrifying. So clouds have to get to that cold freezing layer, and they have to contain ice for that to happen. Okay? So when we have a look inside the cloud here, what happens is we start to get ice in there. We have different things called ions inside a cloud, okay? We have areas that have positive ions or charges and areas of the cloud that might be negatively charged. Thunderstorms, with all the ice molecules slamming and bumping into each other because of the volatile winds, the violent winds inside the storm, these areas of like charges tend to accumulate in the cloud. And most often, not always, this is just an example Hutch is drawing here, the base of a thunderstorm, the bottom of a thunderstorm, is oftentimes negatively charged. And we get these like charges accumulating in different areas of the thunderstorm. So we might have an area of positive charges that accumulate here, another one area of negative charges that might accumulate up at the top of the cloud. We might get some positive charges that accumulate way up over here, okay? So interesting stuff, how the cloud electrifies because of the ice bouncing around inside the cloud. Now, when a thunderstorm moves over your town, so if you're in West Fargo, if a thunderstorm moves over West Fargo, the negatively charged cloud base starts attracting positive charges near the ground to accumulate at the top of high places, like trees. Okay? So when these positive charges start accumulating at high places, and they start reaching up toward the cloud from the ground. And the negative charges inside the cloud start reaching down, we cannot see this yet, in a trail toward the ground. That's called a leader, okay? So the electrical current starts making a path toward the ground here, and the positive charges near the surface that are accumulating on tall places are reaching up toward the cloud. When these two areas of different charges get close enough together for the path to be ionized, is what we call it, boom, we get a lightning strike, okay? So the lightning, once this path is complete, will make a connection between the cloud and the ground, and then the electrons will travel down through that path, and the positive charged ions will travel back up numerous times. And because there's a turning on of negative charges moving down and positive charges moving up, if that's the direction in this example, the lightning strike will light up and go dim and light up again and go dim and light up again and go dim. So that can cause the lightning to flash numerous times in an area. You guys have been great. Now we got to see what's this experiment we're going to do today. All right. Hopefully you got a balloon. It's science, Brando. That's right. Alicia, thank you. Says that my dad TV got struck by lightning. That's not good. It can happen to electronics, so stay away from it. This is a fun experiment. Remember I said that inside a cloud, inside the thunderstorm cloud, we need that ice, and that ice is in there bouncing around and bouncing off each other because the winds inside the thunderstorm are kind of volatile. All of us have probably done this trick, but we're going to do it together. What happens when you take a balloon and you rub it on your hair? Go ahead. Go ahead and start doing that. You create static electricity. Lightning and thunderstorms is static electricity. So Hutch is even going to do this, okay? Rub that balloon. Okay, what are we doing? Just like inside the cloud, I can hear the static electricity starting to form on this balloon. All right, watch what happens to Hutch's hair when I hold it up. You see my hair? It's kind of dark in here. It's standing straight up toward the balloon. Now, we have separated the charges, and we've got positive charges accumulating in my hair and negative charges that have accumulated on the balloon. And I can hear when my hair touches the balloon, little shocks going. Can you hear them? Listen. I can hear shocks happening when I do that. You're making lightning on your hair, okay? Another thing that this teaches us, when we have a balloon, think of the balloon now. The bottom of the balloon is a thunderstorm moving over our town. When that gets close to our town, positive charges start reaching up toward the cloud, toward high places. You see that? They're reaching up, saying, strike me, hit me. A lot of people who have been in an area that have been struck by lightning have said, my hair stood up right before the lightning happened. It's kind of our way of knowing when lightning might strike our area. If you are ever outside or inside and a thunderstorm is around and you feel your hair start to do this, stand up, that is a huge danger sign. You need to get down low as fast as you can, because what's happening is positive charges on the ground are accumulating at the top of your head, and they're reaching up toward the sky saying, strike me. You need to get low, and as you're low, I would duck and cover and get inside, okay? So we learned a lot of safety. We learned some cool stuff here. It's a good idea to have a little bit of fun with this. You can take this now and stick it to a wall, right? Because the positive charges that are on the balloon are attracted to the negative charges. Those have accumulated on my TV screen. And you can let that balloon hang there, okay? You guys, this is fun. Now my hair's messed up and I'll have to do some creative reconstruction, okay? Got to squirt the hair down a little bit to get the charges so that they're not so chargy. And then you just kind of brush her back over real quick. Kind of get ready for the news. A little bit of hairspray right here. And we're good to go, I think. That was a couple out of place. You get the picture. Your questions, time is now. I went about 3 minutes longer than I wanted to, but we had some fun. I got great news for everybody here. I want likes. I want comments. I want you to, if you think that there's somebody that might enjoy this class, link them, or go down to the comment section and go ahead and tag them in that area, and they'll be able to see it. Now, the other thing is we've decided that next week I'm excited to announce we're going to do a couple more. Here in Fargo, students go back to school on the 1st. In Moorhead, you guys go back to school on Monday, the 30th. So we're going to do a couple classes next week, and then we'll play it by ear and see who has time for it, because nobody really knows how our remote learning, distance learning for our school is going to quite work. So how fast does lightning go? Faster than Hutch can snap his fingers. You guys, go ahead and shoot me your questions. We'll do some question and answer. Tiffany, thank you. It's good to see you. You take wonderful pictures. Tiffany's joining us today, and she shares pictures on valleynewslive.com. She's a wonderful photographer. She goes out in her area and takes pictures of clouds. She's taken pictures of barns, sunrises, sunsets, northern lights, all of these things, and uploads them at valleynewslive.com. Do you like to take pictures? Go ahead, log on to valleynewslive.com, upload your pictures, and then Hutch picks out a picture every day, and we use it behind our 7-day forecast, so your picture might be on the news. Casey, thank you. Dana, thanks for coming. Andy Larson, I think I know you. See you at work later. Good to have you here. Hello to Annie and Forehead Hairspray. Thank you, guys. Yeah, I think I'm about put back together again. Again, like Hutch VNL on Facebook. Like Hutch VNL on Facebook. Like Valley News Live on Facebook. Tell your friends. Next week's subjects, Monday, so that you're ready for Monday. I want to give you a heads up. You'll see this on Facebook. We'll advertise it on our channel too, what the subjects are. But we're starting out with Monday Fun Day. Okay? Monday is a fun day. There's no specific topic assigned. What I plan on doing is just all out fun. We're going to have fun. I want you to think about things about, like, while you've been at home, spending time with your family, what have you done? What is your hobby? Hobbies are important. Everybody needs a hobby. We can't just sit here and rub balloons on our head every day, okay? We got to have something that occupies our time. So I'm going to share with you some of the hobbies Hutch does and likes. I might take you on a brief tour of our studio and station so you can see a little bit about how things work behind the scenes. All right, and I'm really looking forward to Monday Fun Day. So make sure you're there. We'll remind you on Facebook. Just make sure you stay connected. Also, on Tuesday, I believe we're talking about, what do we call it when the wind blows really, really fast in a circular fashion? It's really fast in a circle. Kids, can you help me out? type it on there in the comment section. I'll watch. I'm learning to play guitar and bass. Yeah. Okay. Very good for you. That's good for you, Ancient. I'll call you Ancient. All right. You guys are the best. Oh, yeah. What's the answer? What's Tuesday's topic? Wind that's in a hurry, that blows in a real tight circle. Teresa, tornadoes. Tuesday, tornadoes. Tuesday, tornadoes is the topic. Spinning winds, nature's most violent storm. That's true. Tornadoes are nature's most violent storm because they can make the wind blow faster than any other storm that we typically experience, even faster than hurricanes. Okay? All right, you guys are the goodest. Thank you so much for joining me this week. It has been fun. I really do enjoy teaching. I hope you can tell. I enjoy spending time with you. I'll check out your questions and see if I can answer a few of those. And I really, really appreciate you taking time to spend a little bit of that with me. You guys are the best as well. Thanks for watching. Sherry, thanks, Sarah. Thanks all of you. Make sure you leave comments and questions below. And we will see you next week for Hutch's weather class. Have an awesome weekend. Make it good. The weather looks pretty good here in North Dakota, by the way. All right. All right. See ya.